The leading outcome that we'll be covering for this topic will be an LO2 and 3, which is LO2 is explain the working principle of the mechanism, and LO3 will be on analyzing and selection the integration of the mechanism into the mechanical system. So after completing, should able to explain the different of the different type of mechanism, explain the basic operation of mechanism, and apply the mechanism to any system, any mechanical system. So okay, I will just skip this. This one is a normal thing. So what we are going to learn is on this topic, actuating system, and I skip that. Okay, so okay, what is an actuator? So this is a revision from last week. So a revision is actuator is something that produces mechanical movement or motion. Okay, and then the input normally is either electrical signal, air pressure, or fluid motion. So this is input. What we when we talk about input type into the actuator is normally on the pneumatic actuator, hydraulic actuator, or electrical actuator. So for mechanism, there's no input, okay, because it's linkages and so on, macam linkages, gears. Output will be linear or rotary motion, and force and pressure. So for mechanism, mostly later on you will understand that for mechanism there is no input. The input normally will be motion. The input will be normally either linear input, and output will be rotary. So input to rotary and so on. So electrical signal, so for those actuators that have input signal, so if you have, it can be low power or high power, and in case of low power signal, additional circuit is required to drive the actuator. Means that you need to have an amplifier to amplify the signal. Okay? And the working range can be from few microns to few meters. So you may wonder, where does this few microns, what type of actuator or what type of system where you need to have a few microns displacement? Okay, let's I give you an example. I think in the first chapter, in the introduction to mechatronics chapters, I have shared to you about the semiconductor processes. Where semiconductor processes, you have in the front of line, you have the die attach processes, you have the wafer sawing, you have the wire bonding processes. So those processes normally require very small displacement, means that in micrometer, maybe sometimes it will be in nanometer. So this is where you need to have the working range in few microns. And few meters or from meters from centimeter to meter, maybe in example, if in a tractor you need to have displaced the pneumatic actuator to expand the truck to a few to the maximum extension. So maybe in 1 meter or 2 meters. It depends on what displacement that you set. So this one I have explained. We have a 3 main actuator, and this 3 main actuator is actually supported by mechanism. Mechanism, which is the mechanical actuator. And what are mechanisms? So these are the example of mechanism. Okay, first one is linkages. So what you're going to learn is this 6 main mechanism. Of course, this one will be the general mechanism. Okay, so first one is linkages. Second one is cam and follower. Third one is gear. Fourth one is drag and pinion. Fifth one is chain drive, and lastly is belt drive. Okay, for the total 6